G'day guys, in this video I'm going to answer the question, what's the difference between an abstract base class and an interface? This is a question that comes up I think quite a lot in interviews, and it's something that I think a lot of beginners, including myself, struggle with when they're first getting used to object-oriented programming. And I think it's very good knowledge to have in general. So I'm going to answer this firstly from a theoretical perspective, and then I'll show you some practical examples between an abstract based class and an interface. Before I get into it though, if you are not super confident with object-oriented programming principles, or you'd like a refresher, I'll put a link in the description to a video series that I made on OOP principles, so feel free to check that out and come back to this if you like. So as I said, I'll start with the theoretical difference, in my opinion at least, between an abstract based class and an interface. And for me it comes down to the question of, does this piece of code belong in the data contract of the class, or is it an implementation detail? And I understand that you perhaps weren't expecting to hear me talk about contracts in a programming video. That sounds more like legal stuff, but let me clarify what I mean. So the scenario that I've got here is we've got an application that reads weather forecast information from one or more data sources. So you can see on the left here I've got a MySQL data reader, we've got a Postgres data reader, and in theory we could have multiple other data sources. But the idea is we want to read some weather forecast data from a data source, and we don't want to care too much about where the data is coming from. So that's the scenario. And as you might have expected, we've got an abstract base class that kind of takes care of most of the heavy lifting when it comes to actually interacting with the database, which is what we're looking at here. We've got data reader base. And looking at this, we can kind of categorize the parts of the class into one of those two categories, either implementation detail or data contract. So this constructor here, as a consumer of this data reader base abstract class, as a consumer of this, if I'm writing code that needs to use this, do I care about the constructor? Not really. I mean, I need to create a new instance of the reader, or I need to receive somehow an instance of the reader, but I don't really care about the constructor. So it's an implementation detail. I don't really care about it as a consumer. Same thing with this overloaded constructor with host, DB name, user, password, port. I don't really care about that stuff. I just want the data. It's an implementation detail. These fields, again, for host, database name, username, password, and so on, as a consumer of this, I don't really care about it. I don't care about how you authenticate or how you connect to a database. I just want the weather forecast data. It's an implementation detail. This connect function, of course, behind the scenes, you do have to connect to a database or connect to a web service or connect to a file on disk to retrieve the data somehow. But I don't really care as a consumer of this data reader. I don't really care about that, So of course you do have to connect to something at some point, but it's an implementation detail. I don't really care about it as a consumer. Reading the next row. This is probably only really going to pop up if you're dealing with like a flat file on disk where you're reading the file line by line, or if you're working with a relational database and you're getting back rows of data. It's common to have something along the lines of read next row, where you process the data that you get back from the database one row at a time. But as a consumer, I don't care about it. It's an implementation detail. I don't really want to have to see it or worry about it. Parsing a row, the fact that you get your data back in a typeless sort of format, and then you need to parse each piece of data, like CSV data. You need to parse it into integers or bools or other types. Again, it's an implementation detail. As a consumer of this, I don't really care about it. All I really care is this last one. Get the weather forecast data. How you get it, how this class gets the forecast data, that's an implementation detail. I don't really care about it. All I really care about is this method here that lets me get the data that I want. So as a consumer of this data reader base or one of its derived classes, this is all I really care about. So this is what I would expect to be in the data contract. If I'm using this data reader base or one of its derived classes, this is what I care about. This is what I need to use. This ought to be in the contract between me and the thing that I'm using. So all the rest is implementation details. This last function here is what I would categorize as part of the contract. So if we were to take this same abstract class and rewrite it as an interface, it would probably look something like this. All it really has is that one method that the consumer cares about. Everything else is an implementation detail. How it happens is up to the things that implement this interface, and that's pretty much it. And that gives you a lot of flexibility, because it means that even if you're not writing a data reader that connects to a SQL database, you don't have all of that overhead of ports and DB names and things like that that may not even apply if you're reading data from a NoSQL database or a CSV file or an Access database or something like that. So conceptually, that's kind of the difference between an abstract base and an interface. It comes down to splitting up the implementation details from the data contract. And if you put yourself into the position of a consumer, if I want to use this thing, what's the bare minimum that I need to know about? And in this particular case, it's this one method here. That's the bare minimum that we need. That's what belongs in the data contract. So conceptually, that's the difference. But I understand that without some practical examples, it might be hard to really understand, well, when should I use an interface and when should I use an abstract base. So I have a couple of practical examples here as well. Let's start with constructors. So I've got here an abstract class called constructors base, and it has a constructor that has two parameters in it, two integers, x and y. And you can already see down the bottom here, I've tried to do a similar sort of thing with an interface. I've just defined an interface with no parameters, with a constructor that has no parameters in it, and it's coming up with a red squiggly line because interfaces cannot contain instance constructors. So that's a rule. When it comes to interfaces, you cannot define constructors for them, at least not yet. A lot of the limitations around interfaces have changed somewhat recently, but thankfully interface constructors are not one of those things. So you cannot define constructors on an interface. I'm just going to comment this out so that the code will compile. Another difference between, or another practical difference between abstract base classes and interfaces are fields. So we saw in our earlier example, we have a bunch of these fields for host, database name, username, password, port, etc. And here we've got a minimal sort of similar example where we've got an abstract class called fields base, which has these two protected integers. We've got the same thing on an interface. We've got these two protected integers, but they're coming up in red, saying interfaces cannot contain instance fields. That might raise an eyebrow. You might be wondering, well, how can I store information on an interface then if I can't use instance fields? And if you're somewhat new to C#, then that's a perfectly logical question to have. We do have a way to get around that with something that we call in C# properties. So you can define a similar thing like this. So this is a property, and the way that you would access this is pretty much identical to accessing a field. So you would say, something that implements iFields.X, and that will let you access this particular thing. And you can say something that implements iFields.X equals 0 or whatever. You can read and write to this property just the same way that you could a field. But behind the scenes, it's actually using something called a getter and a setter, which are actually methods, and the actual field is hidden behind the getter and the setter, which are methods. You know, there's a method to retrieve the value of x and a method to set the value of x behind the scenes. But yeah, this is a way, if you're wondering about, you know, how would you store data on an interface, you would use a property, not a field. But yeah, that's one other difference between an abstract class and an interface. Instance fields are not allowed on the interface. Another practical difference is when it comes to inheritance. So what's this complaining about? Oh, sorry, let me go back and get rid of that. There we go, much better. So we've got a class here, and it implements two interfaces. It implements iConstructor from the first example, and it implements iFields from the second example, and no dramas. We've got another class here which inherits from constructors base, which is the base class that we have up here, corresponding, I suppose you could say, to iConstructor. And it also inherits from fields base, which is the same one, similar to iFields. But unlike the first example up here, this is actually coming up with an error. And the error is that the class cannot have multiple base classes. So you cannot inherit from multiple base classes at the same time in C#. And I think that this is true for most object-oriented languages nowadays. Some of the older ones like C++, I hear, will allow it, but it does come with its own set of problems. But in C#, and I think most other languages nowadays probably will follow this rule, you can only have one base class. However, as we've seen before, you can have multiple, if you want to call them base interfaces, or you can implement multiple interfaces. So that's another big difference between the two. And you hopefully are kind of seeing the trend that interfaces are quite flexible because of that fact that they don't have any implementation details. They're just contracts. Because they're just contracts with no implementation details whatsoever, no constructors, no fields, or anything like that, they're very, very flexible, and you can reuse them in a lot of different ways, more so than base classes. So you can't inherit from multiple base classes. You can, however, in this third example, you can inherit from one base class and then as many interfaces as you want. Now, it's probably not a great idea to go too crazy with this and implement, you know, a dozen or more different interfaces, but you can implement multiple interfaces and one base class. So that's a difference when it comes to inheritance. This is an interesting one, and if I was making this video a couple of years ago, I would be demonstrating a different difference here. But methods, when it comes to C# now, as of, I can't quite recall which version this changed in, but nowadays you can have a method with a body in an interface. This is a recent change. Up until recently, that was not possible, but as you can see in the base class here, you've got a method called getX. It returns an integer, and it always returns 0. We've got a similar method here on an interface called getX, and it always returns 0. So no difference here yet. This last practical example is going to be more of an advanced one, but I think that it is still very worthwhile going over. So the last difference comes down to mocking. So mocking is something that we do when we want to test a dependency of something. So I might actually start with these two classes here. I've got mocky with base class. It has a function or method called do something, and it takes in a base. This is the base that we looked at in the previous example, methods in base and iMethods. So it basically just calls getX on the instance that gets passed in, and it writes it to the console. And we've got here a similar one with Mocky with interface, does the same thing, takes in the interface, calls getX, writes it to the console. Now, what we want to do, and this is usually what will happen as part of the testing process when you write software, you don't want to pass in the genuine instance, because the genuine instance might be doing certain things that you don't want to happen, or that you can't control, so you can't make it a fair test. Like reading data from a database is going to be a good example. The data that gets read from a database could change quite frequently, so you can't control it, and therefore it's not going to be a fair test. You'd rather have the test in your project something that you can control. So you want to be able to specify the test data, and the test data should be the same every time the test runs. It shouldn't depend on the data that's actually in the database. So how can you do that if you're passing in an object that reads data from a database? And the answer to that is you mock it, where you basically pass in something that looks, as far as the compiler is concerned, looks like it's a genuine instance, but it's actually an instance that you've modified so that it returns data that you want it to return, and not do what the object would have otherwise done, like reading data from a database. So I'm using a package to do this. I'm using a package called mock, M-O-Q, and what I'm doing here is, let me uncomment these. I'm setting up a mock of this base class, and I'm using the package to say, when somebody calls getX, which returns 0 normally, I want it to return the number 99 instead. And then I'm calling this mocky with base class .do something method, and I'm passing in the mocked instance rather than an actual instance. And I'm doing exactly the same thing with an interface. And we saw in the previous example, these two are doing exactly the same thing. So let's see how this plays out. I'm going to jump over to my program. Let me just comment out the rest of this and uncomment this. There we go. All right, and I'm just going to drop a, yep, we've got a breakpoint sitting there, so let's run this and see what happens. Yep, what happened? Right, let me just fix this up. All right, let's try again. Cool. All right, our breakpoint got hit. Let's continue. And we're stepping through. We've got our mock created. We'll set up this getX function so that it returns 99 instead of the actual function, which returns 0. And we've got a problem here. Because it's a base class, we can't actually mock this. We can't replace the actual method with a method that we want to use instead. And that's another limitation of abstract base classes. Let's try the same thing with an interface. So I'm going to comment this out and run it again. Let me just switch over here, clear the console, and rerun it. Okay, cool. Breakpoint got hit. Let's step through. We'll create a mock of iMethods, and we'll set up the getX method such that it returns 99 instead of the default of 0. Let's just jump back even to methods. So the default is, or the actual implementation is for it to return 0. Let's jump back to mocking and step through. Awesome. Switch over to the debug console, and we can see that it returned 99 as per our mock. So that's somewhat of a more advanced example. You may not see this until you start unit testing in your projects. But that's another really big difference between abstract-based classes and interfaces, which may not be apparent when you look at the implementations themselves. These look identical. It looks like they behave exactly the same way, but as you've seen, interfaces in general are much more flexible than abstract-based classes. You can mock them, you can implement multiple interfaces, whereas you can't for abstract-based classes. And so on. So in general, they're just a bit more flexible. Now, I know that was a lot to take in, and you may still be wondering, okay, well, when do I use one? When do I use the other? And if I come back to my program and just close all of the others, I'm going to comment this out and uncomment the rest of this. I think the general rule is for code that is external to whatever module it is that you're working on, always expose the interface instead of the base class. You can, as we've sort of said, base classes deal with implementation details that consumers, such as this display data method that I've got here, this display data method is a consumer of the data reader. It doesn't care where the data is coming from. All it cares about is that it can run this particular method, get weather forecast data. So all of that other stuff that the base class has, it doesn't care about. And for that reason, I'd probably suggest, of course, you know, there are exceptions to these rules. I'd probably suggest for all external consumers, so some other project or even one or more layers above your base class, it's probably a better general rule or rule of thumb to expose the interface and use the interface rather than using the base class. You can still use the base class behind the scenes. So you can do something like this. We've got our data reader base. Your base class can actually implement the interface itself if you want to. So that way you're able to have all of this, you know, the implementation details, the heavy lifting, still be common between MySQL reader and Postgres reader. They can still implement, they can still inherit from the base class, but they also, you probably don't even need this on here now. Because the base class, where are we, implements the interface itself, outside of these three classes, everything else should probably be dealing with the interface rather than the base. That way they only get the contract, none of the implementation details. So hopefully that cleared up some of that confusion. If you do have any questions, feel free to drop them in the comments. And if you have any other requests for videos going over any programming topics or software development topics, feel free to drop those in the comments as well. Thanks a lot. Catch you later. Bye.